In 2023, a freight train derailment in East Palestine, Ohio, created a towering black mushroom cloud of toxic chemicals, forcing an entire town to evacuate. This was no ordinary accident. It was the start of a massive chemical emergency, one that would lead to one of the most controversial decisions in recent disaster response history. And this was the scene, a terrifying black plume hanging over the town, the direct result of what was called a controlled burn. So, how in the world did this happen? Well, in this explainer, we are going to break down the entire chain of failure, piece by painful piece. We'll look at the single mechanical component that started it all, the volatile chemistry boiling inside those tank cars, and the critical human decisions that were made under absolutely immense pressure. You know, the entire disaster didn't start with a bang. It started with a slow, grinding burn inside one single critical component. See, railroads rely on a system of what are called hot bearing detectors, or HBDs. They're basically infrared sensors placed along the tracks. As a train flies by, they scan each wheel bearing, looking for dangerous overheating caused by friction. This is supposed to be the primary defense against this exact type of failure. Now, this slide here tells a story of a failure that's just accelerating out of control. Look at this. At Sebring, the bearing was only 38 degrees above the ambient temperature. Totally fine, no alarm. But just about 11 miles later in Salem, it spikes to 103 degrees. Now that did trigger a non-critical alert, but it went to a remote help desk, not the train crew. And get this, at that very moment, a trackside camera actually saw sparks and fire coming from the bearing. But the crew, they had no idea. It wasn't until almost 20 miles later, as the train was rolling right through East Palestine, that the bearing hit a staggering 253 degrees above ambient. And that is what finally triggered a critical audible alarm inside the locomotive, screaming at the crew to stop the train and stop it now. But it was just too late. The engineers started to apply the brakes, but within a minute, the bearing failed completely. The axle just separated, and it caused this catastrophic derailment of 38 cars, 11 of them packed with hazardous materials, which of course immediately burst into flames. And this quote right here, it perfectly illustrates the fundamental problem. Professor Tarawane points out that these detectors, they're measuring the outside temperature. By the time it gets hot enough on the outside to trigger an alarm, the failure on the inside is already catastrophic. The system is literally designed to detect a problem that, for all intents and purposes, has already happened. So the mechanical failure caused the derailment, but it was the chemical cargo that turned this accident into a full-blown, life-threatening crisis. Let's talk about the main hazard here. 5 of the derailed cars were carrying vinyl chloride. And let me tell you, this is nasty stuff. It's a super flammable gas they use to make PVC plastic. It's also a known Group A carcinogen, and when it burns, it can decompose into phosgene, a chemical warfare agent, and hydrogen chloride, which basically becomes hydrochloric acid inside your lungs. Now, with those cars sitting in a massive fire, the single biggest fear for responders was a runaway chemical reaction called polymerization. Inside a sealed tank, this reaction can generate its own intense heat, creating this terrifying feedback loop that just skyrockets the pressure inside. And that runaway pressure, that could lead to the absolute worst-case scenario, a BLEVE, a boiling liquid expanding vapor explosion. We're talking about a catastrophic failure of the tank, a massive, violent explosion that could hurl shrapnel for up to a mile. This was the one thing everyone on scene was desperately trying to prevent. And that fear of a BLEVE, it set the stage for the most controversial moment of this entire incident. A decision that was made under extreme stress with, as it turns out, fatally incomplete information. So, 2 days after the derailment, a pressure relief device on one of the vinyl chloride cars started venting violently, and then it just stopped. The Norfolk Southern contractor on scene, Drew McCarty, he saw this and thought it was a sign that polymerization had started and was gumming up the valve. As he said later, the way that tank car was behaving, it frankly scared the hell out of us. So based on that fear, Norfolk Southern and their contractors went to the incident commander, the East Palestine Fire Chief, Keith Drobick, and told him a vent and burn was the only option, and he was given just 13 minutes. 13 minutes to make the call. And here, right here, is the crucial point, a total breakdown in communication. You had Norfolk Southern's team on the ground, pushing for this urgent vent and burn. But at the same time, experts from Oxyvinyls, the company that made the chemical, had looked at the data. Their conclusion? Polymerization was not happening. The cars were stable. They told Norfolk Southern this, but that absolutely critical piece of information was never passed on to Fire Chief Drobick. In its final report, the National Transportation Safety Board, the NTSB, was blunt. They said there was no excuse, no argument that could justify failing to communicate that dissenting opinion to the incident commander. It compromised the entire decision. So, after all that, what was the final verdict, and what can we all learn from this catastrophic chain of failures? The NTSB's multi-year investigation was completely unambiguous. After analyzing everything, they confirmed polymerization was never happening. The so-called controlled vent and burn, the one that sent that massive toxic plume all over town, it was simply not necessary. This disaster really highlights both the importance and the vulnerability of the incident command system. See, ICS is designed to put one person in charge to avoid chaos, but that system is only as good as the information that person receives. When key experts are silenced or their opinions just aren't shared, the whole system breaks down. So, what are the big takeaways here? Well, first, prevention is everything. That starts with mechanical reliability. Second, detection systems that only warn you of a failure after it's already too late. That's not good enough. And finally, in a crisis, the incident commander has to get all the information from all the experts. Because as we saw here, communication isn't just important, it is absolutely everything. And for all you safety professionals watching, this is a really sobering question to ask yourself. If you were given only the information the fire chief had, with the threat of a catastrophic explosion hanging over your head, and you only had 13 minutes to decide, what would you have done? Ultimately, East Palestine is just a stark, brutal reminder that in hazmat safety, you're dealing with a long chain of dependencies. A failure in any one link, whether it's a small piece of metal or a critical piece of information, can lead to utter disaster. If you found this breakdown of a really complex incident insightful, make sure you subscribe to our channel. We're dedicated to breaking down these real-world events to help you grasp the critical details that truly matter and protect lives.